Thank you very much. And I suppose I've only really got myself to blame for being here. I spoke to Tom at an event in Birmingham, knowledge transfer. I said, I have an interest in freight, and he said, well, why don't you come and speak? So here I am. But I must thank Tom. I think, it's a real pleasure to be here, and it's a real pleasure to speak to an interested audience who have freight at their heart. So, I'm going to go on to this slide next, and I'm going to ask my opening question. Who has heard of the International Energy Agency's Hybrid and Electric Vehicle Technology Collaboration Platform? I don't think we're doing our job well enough then. Because one of the things we want to do is we want to basically influence policy, disseminate and share information. So, I blame myself for coming here, but perhaps it's opportune because I will like to signpost some of the work that we've done and some of the work that we're currently undertaking. And at the end of this presentation, the last slide said I would like to invite you to contribute and disseminate and share this wider and further. So what is the International Energy Agency's Hybrid Electric Vehicle Technology Collaboration Platform? I'm sure you've all heard of the International Energy Agency. That was established in 1974. It currently has 29 member countries, and its remit is basically to cover energy generation, energy supply, and energy consumption. People miss out the consumption part, but they're intertwined. You don't generate something unless you've got a use for it. So the International Energy Agency wants to basically influence policy. It wants to drive economic activity. It's added to that it wants to protect the environment also, which is obviously all at our heart at the end of the day. And to do this, it established some technology collaboration platforms. So it's engaged currently somewhere in the region of about 6,000 experts worldwide across all continents, engaged on problems of energy generation, energy supply, and energy consumption. And within the technology collaboration platforms, it establishes independent groups. And one of these is hybrid electric vehicles, it's transport. Because transport, as we all appreciate, is a large energy consumer, and it's also responsible for a large amount of pollution, greenhouse gas emissions, and also particulate matter, etc., contributing to local air quality in our cities. And basically what it says, as I said earlier, it wants to network, it wants to disseminate, and it wants to collaborate, both on a national and an international scale. So that's the Hybrid Electric Vehicle Task Force. We've currently probably in the region of about 40 to 45 task force, and these cover all aspects of the transport paradigm. So they cover user acceptance of mobility, how user acceptance is changing. It covers technology, so we look at battery chemistry, recycling of battery materials, and obviously if you're looking at freight paradigm, freight transport is one of those major aspects of road transport, and marine and air, but I'm here to talk about road transport. One of the first tasks that we set up dedicated to freight transport was Task Force 27, Electrification of Transport Logistic Vehicles. This ran from 2015 to 2017, so it is complete, but it does provide some useful information in relation to freight. And as it says on the slide there, I just realized I can see a screen down here as well, so stop looking over there. We all realize that the transport sector is heavily dependent on fossil fuels. I mean, I'm using old figures now, they probably change, but we've got a target of 80% greenhouse gas reduction by 2050. Road transport has a 60% target reduction. And if you look at where that greenhouse gas emission comes from, and the figures I've got to hand, 25% of that in road transport comes from the movement of freight. So freight is a major contributor, but looking forward and looking at projections, while passenger car miles is pretty much growing at a very slow pace, congested infrastructure, people choosing other modalities, we foresee the amount of freight movement to have an aggressive growth relative to passenger cars. So it's 25% now, and if we don't step in and do something, it's liable to be a much greater contributor going forward. So what we can expect going forward is action in this area, and that is basically regulation coming forward. The only real technology in the marketplace for the foreseeable immediate term is electrification. So we've got the regulation, we've got the technology, but there's a warning, and that warning is basically, unlike the passenger car sector, which has had much press, we've seen it in the news all the time, the freight sector tends to be the poor relation. So in 2014, and you must admit this is now 6 years ago, looking at the start in 2015, we identified a lack of information about the status of electrified logistic vehicles and possible fields of application which we wish to correct. So we set up the task force, and what we're doing is basically we're trying to do that networking, collaboration, dissemination. We're not necessarily undertaking the fundamental research. We set ourselves a number of objectives. These are 3 objectives. One was to establish what product there was available, what product was coming through. Second was to establish the use cases, because if you have a particular product, it has a particular use case. But on the other way of looking at it, if you identify a particular use case, that drives the technology development to deliver that product. They're intertwined. And then the third thing was basically we want to go back and we want to deliver policy recommendation. Maybe one of the things I should have added earlier is the IEA activity is sponsored, and it's sponsored by national governments. So in terms of Task 27 and Task 41, I'm the UK representative as nominated by the Office of Low Emission Vehicles. So we've got a direct link. Our reports go a direct link back, and basically, I'm not saying OLEV doesn't consider it, but I hope they do. Our policy recommendations do go back to the UK government, as it does to all the partner organisations, governments worldwide, whoever actually participates. The working method is pretty much standard. We've got desk-based research activity. This is supported by going out to the stakeholders, i.e. people sitting here, and understanding what their concerns are. And then basically we've got public outreach. I'm afraid these text is probably a bit small for those at the back, but typical things are flyers, papers, presentations, and conferences. In Task 27, and there's a website which contains all this information, the key outputs were a vehicle database. This was a snapshot in time, so if you look at the vehicle database, remember it's 2017, not 2020. So we identified a number of vehicles. We also collected data on those vehicles, which allowed us to do some subsequent analysis that we've published. I'm not going to talk too much about it here today, but you can have a look at some of those papers. So that was the product. We also wanted to understand how this product was being used. Freight is a very varied beast. Unlike passenger cars, where we've got basically most people using it for the same activity, freight has a lot of different activities it's got to fulfill. So we went and looked at individual pilots. They're also published on the website, so please have a look. And as I say, we ran a series of workshops. I'm just going to do 1, 2, or 3 slides, just basically giving some indication of some of the information that's available. This is just a look at the sort of vehicle database. We split it down into the individual categories, the N1, N2, N3. We're all familiar with the different categorization of freight vehicles. It just relates to basically the gross vehicle weight. So N1 are more your white vans going around urban areas, N2 are your medium weight, and N3 are your heavy goods vehicles. And what we see there is the product offer mainly relates to battery electric vehicles, and there's a more product offer as you go to the smaller, lighter goods vehicles. Why is this? Why aren't we seeing other electrification pathways such as hydrogen? Well, the studies, and if you look at the papers, the cost per ton kilometre of moving freight for hydrogen at the moment, fuel cell electric vehicles, is about 2 to 3 times what it is for battery electric. So that's why battery electric predominates. It's the most logical, most appropriate pathway at this particular point in time. However, as you go to the larger vehicle, that starts to break down, because you can't basically put the amount of energy into a larger vehicle to achieve those distances that heavy goods vehicles go. So we see a creeping in at the heavier goods vehicles of alternative pathways. If we look at the some of the data that we can basically drag out of that database, obviously, what does the customer want? They want to basically use the vehicle, they want to go places. If you look at the range of these vehicles, it's very limited compared to their diesel competitors. If we look at the payload, this is something that's specific to freight, not to passenger cars, then obviously we see the payload is basically less than what we can achieve with diesel vehicles, especially when you go to the N3 category. So we've got a range there, we've got up to 30 tonnes, but the green line represents the average, and that average is very close to the bottom of that range. So there's a lot of vehicles around that 10-tonne range, but not many which are basically giving you a payload far higher than that. So current performance limits expectations. I'd just like to sort of run through some of those key points from the workshops. These workshops are international, and they may all be European where we held them, but they represent participants from 3 continents. So what we did is we had a theme around each workshop, trying to explore what they saw as the problems and the challenges in freight. And for the first one, which was basically electric transport logistic vehicle technology application, the main messages here was they didn't believe the technology was the barrier. The technology is there, it's in play. Yes, it needs to deliver more, but it's available. They saw the application of that technology as the real challenge. The application in terms of the cost. They were complaining that the basic cost of putting these electric freight vehicles in was far higher. The usage cost was lower, but the purchase cost was higher. How do you offset that purchase cost? And the strange one there is about outages. So we're not talking about failures, we're talking about downtime of those vehicles. The uptime was reduced, mainly because of lack of understanding of what those vehicles were capable of. So education is key to get these vehicles into the fleet. If we went on to Amsterdam, this was in 2016, the messages here were about the framework. We've got early adopters who take on these vehicles, mainly because it gives them a unique selling point for their business, the green element. They're not sufficient if we want to decarbonise freight transport. What we were saying here was we need to basically create a framework whereby we move the whole system sideways. So we basically encourage everyone to move up. And we can do this 2 ways. We can do the stick and the proverbial carrot. So we can basically force people by excluding certain types of vehicles being used in certain areas, the low emission zones in cities, for example. But we can also provide some elements of carrot, so we can basically, as it says there, we can reward the front runners with subsidies, parking, loading spaces. But all these aren't within the remit of the freight operator, they're within the remit of the local authority who operates the road space. The one in Vienna, this was now going a bit further. What they identified was that, in actual fact, even if we improve the vehicle offer itself, we don't believe is going to match, like for like, what the offer is there at the moment. So you're not going to get an electric vehicle that offers the same user functionality as the previous diesel vehicle. In actual fact, what we believe is there has to be a movement on 2 fronts. You have to be a movement on the vehicle, and you have to have a movement on the business model. And it's the business model that I'm thinking relies on that data. We have to have more data, big data, to allow these new business models to come to the front. So fleet integration advisory, on-demand availability, routing according to payload is important, deliver heavy goods first. Basically change the way that you operate to basically take account of the fact that these newer types of vehicles will not let you do the same as you've been doing previously. We had one in Coventry, the UK approach. We said there's a framework emerging in the UK for electric freight vehicles. Not so much that we basically target electric freight vehicles, but we target passenger cars. And because passenger cars have moved on, some of that learning can cascade into the freight vehicles, certainly the N1 sector. We got planned and ongoing pilots. The fact is, one of the problems that came up is the people who are operating these electric vehicles, they are nervous. And what they do is they want to do a route of, say, 60 kilometres, and they purchase a vehicle that's capable of doing 100 kilometres. Their contingency, their measure of contingency for these vehicles is far larger than they would ever accept for a diesel vehicle. So they're paying more for the vehicle, they're using it on a route which is basically more than capable of doing. It's costing them. If you could align better the vehicle performance to the routing, you could actually save costs that way. right from the start. So this is the website. You'll find a lot of information on there, our presentations, our papers, digging a bit deeper. As I said, I'm just signposting at this point what we've actually got available on there. You've got vehicle database and project profiles as well. But I just want to go quickly, if this allows me to, onto what's currently ongoing. So this is Task 41. We realise this sector is very, very fluid. What was there in 2017 doesn't represent what's here now in 2020. So we basically argued and got support for another Task 41, electric freight vehicles. It's 3 years duration. It finishes in 2022, and they're the participants. As I say, we are more than just the participants. We basically link into a much larger network of organisations, international organisations. They're there on that slide. The objectives are really to continue what we did in Task 27, monitoring technology progress, monitoring cost developments, looking at what policy frameworks are in place, both in the UK and further afield. And obviously, we are always looking towards what those policy frameworks want to achieve, which is CO2 emissions reduction, but we're also accounting for our stakeholder community by saying, actually, they're looking at total cost of ownership, so there's a balance between the two. We want to deliver environmental protection, but we want to do it in a way that meets the requirements of the freight transport sector. The scope of the task, we've got the vehicle segments at the top, we've got the infrastructure at the bottom. You may notice internal combustion engine and diesel in that diagram there. You're thinking, why is that in there when you're talking about electric freight? Well, there's two ways of looking at the progression and diffusion of electric vehicle technology. One is we incentivise and we develop electric freight vehicles. The other is we introduce policies, legislation that makes the operation of internal combustion engine vehicles more expensive and more difficult. So the tipping point between when an EFV becomes beneficial compared to a diesel engine is not fixed. So we want to understand where that tipping point is and how that tipping point is changing as basically technology develops and policy support for EFV on the one hand, and there's other policies in place which are going to basically look at making diesel less attractive for the freight operators. And this is one of the reasons why we're basically saying it's not static. We can see there that although in 2018, which is where we dropped off on T27, there was quite a population of product offer in the N1 category. In the N3 category, they were mainly vehicle converters. So they took existing product from the OEMs, they took out the diesel drivetrain, and they put in electric vehicle drivetrain. That's changing going forward. As we go to 2019-20 and 2021 onwards, we see a lot more OEMs coming into these larger segments of the freight vehicle market. So we believe there's going to be growth in that area, and we want to understand how we can support that. This is the work programme and how we're going to deliver it. I'm going to go on through these. You'll have the presentation. But I just wanted to give you 2 slides or 3 slides on the progress. We started 2019. We've had our first workshop, which was in Stuttgart. I'm going to pick up on the second one of those activities we covered at the workshop, which is charging infrastructure, costs and availability. This was a presentation from our partners at ProEME, which is promoting electric mobility in Europe, and they quite nicely encapsulated what's happening in the freight sector. Up to this point, we've basically been seeing back to base. So we have electric vehicle in our fleet, it goes out, does its duty, comes back, plug it into a charger, ready for the next morning. And we basically plan our freight movements upon that premise. Now we're seeing a number of pilots being rolled out, where we're charging while it's being used during the day. So it moves from base to where its destination is, and then is basically being recharged. So these are 2 examples. Case 1 is a fixed route between point A and point B with rapid charging at both ends, 350 kilowatt hours, which if you're thinking about the distance, needs about 40 minutes charging at either end, so you can charge and unload or load at the same time. And case 2 is basically shorter distances going from a fixed base, but charging during the day. However, that is what's happening at the moment. Going forward, we're going to be looking at smart, planned charging integrated into the routing. So, are you aware of the Swedish experience with inductive charging and catenary system? That's where we believe we'll be going further on. So we're basically in the middle here, we're piloting these back to base, but eventually we'll go on to this basically integrated into the road network. And that's what this diagram is saying here. We're moving from what is in the orange, where we've had basically 50 kilowatt back to base charging, 50 kilowatt because that's what we use for passenger cars, so that's what we tended to use for our commercial vehicles, to basically the one below is the 350 kilowatt at various points in our range, only onto the dynamic charging as we're basically moving around our road network. So there's a number of challenges and problems. The challenges really are around the operation. We've got to change the way that we think about our business models to take account of the limitations of the technology that's coming through. And the problems are, well, how do we roll this out? How do we basically manage this transition from where we are now to where we're likely to be in the future? And that means basically bringing in new stakeholders, new forms of data in order to support that transition from one to the other. So, as I said earlier, we are about networking, we are about dissemination. I have the knowledge in there which you can pick up on, but you also have the knowledge, and we'd like to integrate that knowledge into this activity. So take the information there, please get in touch or contact me for a business card. I'll happily share the business cards. But this is only as good as the contributors who feed into it. Thank you.
Thank you very much, Huw. I think we'll allow time for one question maybe, because I know you're probably all gagging to grab a coffee. So if we've got a question, otherwise we'll deal with those later on.
Hi, I've just got a question in terms of the charging infrastructure. I assume for like the N3, you're essentially going to need like a super fast charger. And is anyone rolling out those networks in the same way that Tesla has with like for the passenger cars? Is anyone actually kind of doing that in advance for some of the freight operators?
I only just got part of the question, so if I don't answer it correctly, I'm at the coffee break. The demands of freight are very different to the demands of passenger cars. To make passenger cars successful, we need a geographically dispersed network, because everyone goes from point A to point B, and everyone's point A and point B is very, very different. The movement in the freight transport sector is from this back to base where we charge overnight as what the freight sector considers slow charging, the passenger car very fast charging, to this cases I showed very, very quickly, and I apologise for going very quickly, in Germany and the Netherlands, where the freight sector has got very specific routing, where they then put those charging heads at value points where the origin is or where the destination is. So that is going to be a very specific charging network, specific to particular niche use cases. The problem I see there is on a sort of economic level playing field. If you put a certain charging capability into a certain route, that route is going to be more attractive to that particular technology. And if that technology is supported by policy, then you're distorting the marketplace. It's a bit like when I worked many years ago on non-linear goods vehicles, and there was an argument there about if you're allowed to be used on certain routes, then only people with depots along those routes would benefit economically, and that would skew the market for those particular organisations, and not the other organisations that had depots which are much further away from that non-linear goods vehicle or that motor. So it's a difficult thing because the charging infrastructure is going to be invested by, in some cases, public money, but it's going to provide a benefit to certain stakeholders and not to others. So how do you square that circle?